In this video, we are going to see about analog Butterworth filter. We can design a analog Butterworth filter using a 7-step procedure. So step 1, draw the frequency response. From the given specifications. So analog Butterworth filter, we will have specifications which consist of two axes. One is omega, its units is radian per second, and another is mod of h of j omega. So omega p is called the frequency passband frequency, omega c is cutoff frequency, and omega is stopband frequency. AP is the passband frequency gain and AS is the stopband frequency gain. So step 2 is to find the order of the filter. Okay, we have a formula for finding an order of the filter where n is greater than or equal to log of lambda by epsilon divided by log of omega s divided by omega p, where lambda is equal to root of 10 to the power 0.1 alpha s minus 1, epsilon is equal to square root of 10 to the power 0.1 alpha p minus 1. If the specifications are given in gain, we will have lambda is equal to 1 by a s, that is stopband frequency gain, to the whole square minus 1, and epsilon 1 by ap, that is passband frequency gain, to the whole square minus 1. In step 3, we will round up the n. Say if n, we will get a value of n as 3.38 like something, we will round it off or seal off to its higher integer, that is n is equal to 4. So we move on to the step 4. In step 4, what we going to do is we will write the transfer function h of s of the filter for omega c, that is cutoff frequency, is equal to 1 radian per second. We have predefined values of transfer function h of s for omega c is equal to 1 radian per second. So if the order n is equal to 1, the h of s will be 1 by s plus 1. If the order is 2, h of s will be 1 by s square plus root 2s plus 1. If the order is 3, then it will be 1 divided by s plus 1 multiplied by s square plus s plus 1. If the order is 4, it will be 1 divided by s square plus 0.76537 s plus 1 into s square plus 1.8477 s plus 1. So we move on to the step 5, that is we will find the cutoff frequency omega c. So to find the cutoff frequency, there is a formula which is given by omega c is equal to omega p divided by epsilon to the power 1 by n. The unit is radian per second, where epsilon we already know is equal to square root of 10 to the power 0.1 alpha p minus 1, or if it is given in specification as gain, it will be 1 divided by ap to the power square minus 1. To move on to the step 6, that is we will find the transfer function of the filter, that is ha of s. For low pass filter, we will replace s in h of s, which we found in the previous step, with s divided by omega c. For high pass filter, we will replace s in h of s with omega c by s. Now we move on to the step 7, in which we will find the poles of the filter. Substitute the known values of omega c in the formula sk is equal to omega c e to the power j phi k, where the value of k ranges from 1 to n. Phi k is equal to pi by 2 plus 2k minus 1 divided by 2n multiplied by pi, where k ranges from 1 to n.